Students, I welcome you in today's session of physics. As you know very well, in our previous lecture, we had discussed interference of light. This is your chapter number 20 of optics. And in this chapter, we almost cover the principle of superposition. Clear? After that, we had discussed the interference of light waves. Fine. Then we come to Young's double slit experiment. This is the experiment we had also discovered in our lecture number 1. Fine. Explanation of the formation of fringes by wave theory. Then we come out to over here condition for constructive and destructive interference. These things we also discussed in our first lecture. So now today this is the lecture number 2 and we are covering from here constructive interference, because we have already find out intensity, resultant intensity at point P. I hope you know very well what I taught in your lecture number first. Fine. So today we will discuss about constructive interference. So you can see here from the equation number 5 that the intensity, there is an equation number 5. If you see here in the above equation, this one is your equation number 5 here. Clear? So from the fifth equation, the intensity of light at point P is maximum when the cos phi is equals to 1. That is, and the value of cos phi phi is 1 when cos theta or phi considered to be 0. In that case, the value of cos is equals to 1. That is the maximum value. So we put here 0, 2 pi, 4 pi, that is even multiple. Clear? Here you can see we can take here the even multiple 0, 2 pi, 4 pi, 6 pi, 8 pi and so on. So in we can write it like this: phi is equals to 2 m pi, where m is your 1, 2, 3, whatever you put here. So from equation 5 we have maximum intensity, this one, how much? I max is equals to I1 plus I2, that's saying this formula, plus 2 root I1 I2, and in place of cos phi we have to put phi equals to 0 degree. So we will get this expression like this form: root I1 plus I under root 2 means whole square equals to k times of A1 plus A2 whole square. Clear? So this is the final expression you will get after putting the value. This is your maximum intensity. So at point where the two interfering waves meet in the same phase, that is the phase difference between them is how much? 0, 2 pi, 4 pi. The resultant intensity is maximum. So you have to remember this point. So its value k A1 plus A2 whole square is greater than the sum of intensity k A1 square plus A2 square of the two waves. So at this point the resultant amplitude R is equal to the sum of amplitudes A1 plus A2 of the two waves. This is constructive interference. We can find the condition for constructive interference in terms of path difference, where x between interfering waves. So we already know that in the previous lecture we proved this formula how path difference related to the phase difference. So there is a relation between path difference and phase difference. X is equals to lambda by 2 pi multiplied by phi. Fine. So as you can see here, for maximum intensity we considered phi equals to how much? 2 m pi from this relation. So we put here in place of phi, x is equals to lambda by 2 pi into 2 m pi. So from this relation 2 pi and 2 pi are cancelled out. So we can write here x is equals to m times of lambda, means path difference related with the wavelength of light. So the intensity of light at a point is maximum if the path difference between the interfering wave at that point is 0, or you can say that the integral multiple of wavelength is 0, lambda, 2 lambda, 3 lambda and so on. I hope it is clear. Now we will talk about destructive interference. So from the same equation number 5, that the intensity of light at point P is minimum. What happen if the minimum condition for minimum, the cos should be equals to the minus 1. Fine. So in that case, if we put the cos is equals to minus 1, we get the odd multiples of phase difference. So here you can see this is the odd multiple of phase difference: pi, 3 pi, 5 pi, 7 pi, 9 pi, etc. So we can write here this expression like this: phi is equals to 2m minus 1 multiplied by phi. Fine. So in the above expression we found out the maximum intensity. Now here we are finding out the minimum intensity. Clear? So in the same formula which we prove for the intensities, resultant intensity at point P, this from this formula we put cos phi equals to how much? Minus 1. So we get the relation like this form: I minimum is equals to I1 plus I2 minus 2 under root I1 I2 is equals to I1 root minus I2 whole square equals to k times A1 minus A2 whole square. Fine. So, at point where the two interfering waves meet in opposite phase, that is the phase difference between them is 0, 3 pi, 5 pi, the resultant intensity is minimum. So, you have to know very well or remember it where the intensity is, when the intensity is minimum and when the intensity is maximum. So, its value k of A1 minus A2 is less than the sum of the intensity of the two waves. At these points, the resultant amplitude R is equal to the difference of the amplitude, which is your A1 minus A2 of the two waves. So, if the amplitude of the two waves be equal, means if the two waves which are travelling with the same amplitudes A1 equals to A2, then what happen? The resultant intensity at these points becomes 0. You can see here from this relation, if A1 is equals to A2, then resultant intensity comes out to be 0, and this is your the destructive interference. Fine. And what happened with the constructive interference? Here you can see in the constructive or maximum intensity resultant the same phase, that is the two interfering waves where are in the same phase, then we get the maximum intensity. I hope it is clear for you. So, the destructive interference in terms of path difference, if we write this relation in terms of path difference, so we know the formula very well, x is equals to lambda by 2 pi of phi. So, we have for minimum intensity, we put here in place of phi this value, phi equals to 2m minus 1 into pi. Clear? So, write this value here and you get the relation between path difference and phase difference. Now, this changes to the wavelength. So, x is equals to 2m minus 1 multiplied by lambda by 2. Clear? So, thus the intensity of light at a point is minimum if the path difference between the interfering waves at that point is an odd integral multiple of half wavelength, means lambda by 2, 3 lambda by 2, 5 lambda by 2, 7 lambda by 2, because you can see here this is the half wavelength. So, as we move on the screen, the path difference between the two waves gradually changes and there is a variation in the intensity of light being alternately maximum and minimum. This is called the interference pattern. So, if we combine the maximum and the minimum intensity, this is the equation number, you can say that for minimum intensity, you can see that this is the equation number 7, and for maximum intensity, you can see here this is for maximum intensity the relation. So, finally, the relations comes out to be like this: I max upon I minimum equals to A1 plus A2 whole square divided by A1 minus A2 whole square. Now, the interference energy conservation, this is the optional, so I am skipping this. Fine. And now we will move to position of maxima and minima in Young double slit experiment, which is your fringe width determination of wavelength of light. Fine. So, as you can see here, let S from the figure number 4, S be a narrow slit illuminated by a monochromatic light, which is your S1 and S2 be the two placed narrow slits placed in the plane of slit S very close to each other and equidistant from S. Fine. So, here you can see this is the figure. The light from the S reach S1 and S2 is in the same phase. So, I hope you know the Huygens principle, which we are discussing the wave nature of light. So, from there, according to the Huygens principle, S1 and S2 act as a light source from which the secondary wavelets originate. Clear? So, these two sources S1 and S2 serve as a new light source of coherent light source because waves emerging from them originate from the same wavefront. Clear? Therefore, maintain a constant phase relationship. So, these wavelets from interfering fringes on a screen, on measuring the width of these fringes, the wavelength of light can be calculated. So, you can see here from the figure number 4, this one. What will happen here? Let the right bisector CO of the double slit S1 and S2 meet the screen at point O. I hope you know the bisector. Clear? So, you can see from the figure the right bisector CO. Where is CO? This one. That you can say the principal axis of the double slit S1 and S2 meet the screen at point O. At this point of the screen, the secondary wavelet from the coherent source S1 and S2 meet in same phase, means S1O and S2O. Fine. Both are interference constructively to give rise a bright fringe called the central bright fringe or zero order bright fringe. This is the principal maxima. So, in the point O, you will get the central bright fringe or maximum intensity of the light, or zero order fringe you will get here. Let us take another point P on the screen, which is distance small x from O. You can see here we are considering here another point P, which is at a distance x from O, here this one. The point P may be the point of maximum minimum intensity of bright or a dark fringes. It is depending upon the path difference. So, you can see here S2P and S1P, this one S2P and S1P between the secondary wavelets coming from S1 and S2. Now, if we want to calculate the path difference S2P and S1P, let us draw a perpendicular from there. You can see we draw a perpendicular from S1 over S2, this one. Clear? From the source S1 to the path difference between the two waves at the point P of the screen is how much? S2P minus S1P is equals to S2P minus AP. You can see here this is the path difference from A to P, or you can write it S2A. Clear? So, from the right angle triangle you can see this is forming a right angle triangle S1, S2 and A. This is the smallest triangle forming a right angle triangle. So, using this triangle we can write like this: sin theta is equals to S2A upon S1 S2. Fine. And from the right triangle POC you can see another right angle triangle which is forming through POC, this one PO and C. Now, we are considering this triangle, so we can write it tan theta is equals to OP by OC. If now theta is very small, then what happened? Sin theta is nearly equals to tan theta. So, we combine the equation 1 and 2. This is your equation 1 and this is your equation number 2. So, what we get here? S2A upon S1 S2 is equals to OP upon CO. Fine. Now, what is S2O? We have to find out the S2A, and S1 S2 is equals to D. There is a distance between the two slits. Here you can see S1 S2 there is a distance is small d. So, in place of S1 S2 we put here small d. And what is OP? OP is your x. You can see from the figure here OP is given equals to x. And what is CO? CO is equals to capital D, this one. So, we put all these values and finally we get here the path difference between the waves coming from S1 and S2 at P of the screen, how much? S2A is equals to XD by capital D. Fine. Now, we will discuss about the position of bright fringes. So, the intensity of light will be maximum at those places where the phase difference between the interference light waves or path difference is 0 or an integral multiple of 0, lambda, 2 pi, 3 lambda. Hence, for maximum intensity of bright fringes, this expression should be used. So, XD by D is equals to m lambda. Fine. So, where m is equals to your 1, 2, 3 multiple numbers. Therefore, in general, the position of mth bright fringe with respect to the central bright fringe, which is O, is equals to, here you can write this formula, maximum intensity of bright fringes xm is equals to md times lambda by small d. This is the relation. So, it should be noted here that the position of zero order bright fringe can be obtained by putting m is equals to 0. Fine. Means the bright fringe, where we get the maximum intensity bright fringe? Here in place of O. At this point we get the maximum intensity bright fringe or zero order fringe, as we already discussed. So, now from this equation, this is your equation number 3. The other bright fringes, say first, second, third, will be at a distance how much? In place of m you can write it the first fringe, second fringe, put the value of 1, 2, 3 over m and you will get the first, second and third fringe. Clear? On the either sides of the central bright fringe. Now, we talk about the position of dark fringes. So, the intensity of light will be minimum at those places where the path difference between the interfering light waves is an odd integral multiple. So, when you get the minimum intensity, then you get the dark fringes. Clear? So, the difference here you can see difference between the interfering light wave is an odd integral multiple of lambda by 2, 3 lambda by 2, 5 lambda by 2, For minimum intensity, the dark fringes we have xd by capital D equals to 2m minus 1 of lambda by 2, and finally you will get the expression like this, m minus 1 by 2 of lambda. Or the position of mth dark fringe with respect to the central bright fringe can be given by this expression, which is your xm m minus 1 by 2 of d lambda by d. So if you put here m equals to 1 in this formula, we get the position of dark fringe. Putting m equals to 2, you will get the position of second dark fringe, and so on. You can also put 3, 4, 5, 6 and you will get the position of third, fourth and fifth dark fringes on the either sides of the central bright fringe. So this is the formula for the dark fringes, and in the above formula which we discuss about the bright fringes, so where the maximum intensity, you will have to use this formula. This is for the bright fringes. Clear? So as comparison of equation 4 with the equation 3 shows that the dark fringes are situated exactly in between the bright fringes. Fine. So you will get the pattern like bright dark as. Now if you have to calculate the fringe width, so what we use here, the distance between the two consecutive bright or dark fringes is called the fringe width. This way. Clear? So today, student, we are closing our class. We will discuss this fringe width in our next lecture. Till that, do study. Thank you, class.